In this video lesson, I'm going to show you a very simple technique on how to simplify using rational exponents. In the first case here, we're looking at a generic radical whose index is m and whose power of x is n. How to take this and write this in a rational exponent form, we're going to do the following. We're going to use the base, which is the radicand, and we're going to raise that to the n over m power. So my index becomes my denominator. From here, we'll do a very simple example, something where we have a radicand of x squared and an index of 3. To rewrite this as a rational exponent, this would become x to the 2/3 power. The next step is I want to take that and look at that and see if I can simplify that further. If your numerator is less than the denominator, then I know that I can't simplify this any further. Also, we can tell by looking at the radical form that I could not simplify this radicand further. Another type of example on simplifying is when you have a rational exponent with different denominators. So the concept is to find a common denominator. Once you find the common denominator, we'll then rewrite as a single radical. And then once we do that, it should make simplifying the radical a lot easier. This is one technique that I like to use. Common denominator is 12. I'm going to multiply my numerator by 4. Multiply this numerator by 3. And now I'm going to rewrite the expression so I have a clear visual as to how I'm going to now rewrite as a single radical. So my index is 12, the denominator of the rational exponent. The power of x is 8, and the power of y, or the exponent of y, is 15. Now from here we can simplify the radical. Since 8 is less than 12, I cannot simplify x, or 12 cannot divide evenly into 8, so I cannot simplify the x. 15 is greater than 12, so I know I can simplify that. 12 divides into 15 once, so I will take out 1y, and I'm left with 3 left over, 3 y's left over. Since this is an odd power with an even index, I'm going to use the absolute value so that my value for y, should it be negative, will not be a negative radical, which would be an imaginary answer. Second examples, you have the same base, x and x. The way we treat these is like we treated exponents where the bases were the same and you were multiplying and dividing them. And the first example, since we're multiplying using the same base, we're going to add exponents. And then, of course, always look to simplify. In the case of division with the same base, we're going to, again, dividing using the same base, we're going to use the rule of subtracting exponents. And then, of course, simplify where appropriate. First example, we have a common denominator, so I'm going to add my numerators. This becomes x to the 9/5 power. Here I can simplify this expression. And again, I like to rewrite it in radical form. Makes it a little bit easier, I think, to simplify. So 5 divides into 9 once, one group of 5, and there is 4 left over. That would be your final answer. In the second example, I'm going to treat this into 2 parts. One for the fractional part to reduce it. So we'll reduce the fraction. So we'll divide the numerator and denominator by 5. So I'm left with 3/4. Then I'm going to find a common denominator and subtract exponent. So I multiply my numerator by 3, subtract the exponent, so this becomes x to the 12/9 power, x to the 7/9 power, and if I subtract exponents, I get 3x to the 5/9 power over 4. Since my numerator is less than the denominator, I can't simplify this any further, so this is an appropriate form to leave your answer in, or if you so choose, you can rewrite it in a radical form if that helps you see things a little bit better. I hope you enjoyed this lesson on rational exponents and how to simplify them using some basic properties.